సామాన్య విభజనపై అనువర్తన సమస్యలు. ఒక యంత్రంపై ఉత్పాదింపబడే పరికరం యొక్క జీవితకాలము 12 నెలలు మరియు దాని విభాజనం 2 నెలలు అయితే పరికరం కనీసం 8 నుంచి అంటే లాస్ట్ వీక్ చెప్పుకున్నాం X-(m/σ) 7-12 అనేది చెప్పుకున్నాము. ఇది కూడా 1000 మార్కుల మధ్య లాస్ట్ క్లాస్లో ఇది కూడా నేను టీచ్ చేసిన. ఇది కూడా క్రమ విచలనం ఇది కూడా చెప్పుకున్నాం మనం. రెజిమెంట్ కూడా మనం చివరి లాస్ట్ క్లాస్లో చెప్పుకున్నాము. ఇక్కడ చెప్పాలి. సామాన్య విభాజనలో 7% వస్తువులు 35 లోపు మన 63 రూపాయలని క్రమ విభజన కనుగొన్నాం. ఇది కూడా మనం లాస్ట్ క్లాస్లో టీచ్ చేస్తాము. సో మనం ఇప్పుడు సామాన్య విభజన అనువర్తనాలు.
Hello. So we completed applications, right? Of what? So I think we completed 3 examples of gamma distribution. So once again, we'll have a glance about the gamma distribution examples. Then we'll go for the next distribution, beta distribution. So I hope you understood, but like applications part, right? So we will do once again. It is important. So coming to the first example. So what is the first example? First example is the daily demand for the milk in a certain locality per month is known to be gamma variant. So what they are saying, the demand for the milk. We are asking demand for the milk in any locality, like in a certain locality per month they are taking. It's gamma variant. We are assuming it as a gamma variant. So if the average demand is 60,000, what they are saying, the average demand is 60,000 liters. And the mostly likely demand, what are they saying? Mostly likely demand, they are saying. Mostly likely demand. Means mode they are giving. Mode is equals to 59,980. So this is the gamma distribution mean they are saying. And this is mode. They give mean and mode of the milk distribution. So now what we need to do, what is the variance of the demand? So we need to test the variance. What is the variance of the demand? So from that in the gamma distribution, so mean is equals to what? Mean is equals to formula we have. So mean is equals to what? P by lambda. P by lambda. So they already gave what? P by lambda, that is mean as 60,000. Mean as 60,000. Mean as 60,000. So 60,000. Mod is what? Mod is equals to P minus 1 by lambda. P minus 1 by lambda is equals to 59,980. If we do like P by lambda is equals to 60,000 and P minus 1 by lambda is equals to 59,980, then you can conclude, like if you both equate it, then we'll get what is the lambda value and what is the uh, uh, p value. So from these two equations, we'll get lambda value as what? 0.05. And what is the mean p value? P value will be 3,000. P value will be 3,000. So now what is the formula for the variance? You all know variance of the gamma distribution is what? Gamma distribution is P by lambda square. P by lambda square. So P by lambda square is what? P is 3,000. And lambda square is what? 0.05 whole square. They are adding 0.05 whole square. It will become 0.005. Then if we uh, do like this, then we'll get as a 12,000. So 12,000 is the variance of the milk distribution. So coming to the next example. So next example, what they already gave the f of x value. So what is f of x value? F of x value is 2 into e power minus 2x. For what condition? X is greater than or equals to 0 and 0 otherwise. 0 otherwise. So what they are saying, what is the probability? X is more than 2. They are saying x is more than 2. Then what is the probability they are asking? So we will use the function f of x is equal to, what is the function? So f of x is equals to lambda p by gamma function p e power minus lambda x minus lambda x. They already gave what? 2 into e power minus 2x. So from this we can assume, so in the place of p, 1. So from this equation, like let me explain. So if you keep p as 1, this p as 1 and lambda as 2, you'll get the this only. So we'll see. Lambda, what is lambda value we're taking? 2. 2 power p. P means 1, 1. So into e power, what e power? So e power minus lambda minus 2 x by function of b. It will become 1 only. So same function we are getting here also, right? So p is equals to 1, lambda is equals to 2. So now what we need to do? We need to do probability of x greater than or equals to 2. Probability of x greater than or equals to 2. So what happens? This 2, what we are taking the function will come outside. Will come outside. So it will come outside, and what is the integration part? Integration 2 to infinity e power minus 2x into dx. For this, we will do the integration part. 2 will be outside. If we do integration for this part, so it will become e power minus 2x by 2. And minus is there, right? It will come minus. Outside 2 is there, right? 2. 2 into e power minus 2x by 2. So what is the part? Integral part, infinity to the 2. So we will substitute the 2 e power minus e power minus 2 into 2, 4 minus 4x. Then by 2 into 2, this 2 can be cancelled. Then we'll get minus e power 4. Minus e power 4. Minus 4. So the value of that is minus e power minus 4 is, the value is 0.0183. 0.0183. Next, coming to the third example, the water consumed in a building per month is assumed to be gamma variant. So what they are taking in as example, so the water consumed, they are taking water consumed in a building per month is assumed to be gamma variant. With mean what? The mean, this is similar to the first question, right? So they already gave the mean, they gave the what mode also. So what is the thing we need to find out? We need to find out the f of x value. The condition we need to, the probability density function, PDF we need to find out, PDF of water. And the first question, they already gave the PDF and they gave the mode and mean like that. So here they gave mode and mean. So from this we need to find out the PDF function. So okay, let's. So what is the mean they give? Mean is equals to 40,000. So it is represented as P by lambda. Again, we have a mode. Mode equals to what? 39,933.333. So it is represented as my P minus 1 by lambda. P minus 1 by lambda. Then from that we will find out the lambda value. What is will be the lambda value? 1 by this. One, lambda is equals to 1 by mean. Means mean. Okay. Lambda is equals to mean minus mode. Then we'll get the lambda value. So from that lambda value, we can easily substitute the lambda value here. It means P by 0.015 is equals to 40,000. So then what is the P value? P is equals to 40,000 into 0.015. So the P value becomes P is equals to 40,000 into 0.05 is 600. So the P value is 600. So what is the function we have? The function, this is the function, right? What is the function formula? F of x equals to lambda power p by gamma function of p into e power minus lambda x. what is the work we need to do now? We need to substitute the lambda and p values there to get the f of x. So I'm getting it right. F of x is equals to, so what is lambda value we got? Lambda value is 0.05. So 0.015. P, what is the p value? P value is 600. Whole power 600 into e power minus lambda is what? 0.015 x by function of 600. So this is the thing where x is greater than or equals to 0 and 0 otherwise if this condition does not work. So this is the third example. Then the fourth question is the daily consumption of milk in a city in excess of 20,000 liters is approximately, they are saying excess of 20,000 is approximately what? Distributed as gamma variant. It is distributed as what? Gamma variant. With the parameter what? Parameter is equals to lambda is equals to 1 by 10,000, 1 by 10,000. And p is equals to what? They gave already the lambda and p values. For the city has a daily stock of 30,000, what is the probability stock is insufficient on the particular? So they are asking what is the probability that the stock, when the stock is insufficient on that particular day, then we need to find if the stock is insufficient, what is the probability of having insufficient stock. Again. So we are denoting the daily consumption of the milk in a city. Let it will be X. So what we are assuming? So we are assuming it as X. Then what is the Y value? If there is sufficient, right? So Y is equals to what? That X minus what we have, that 20,000 as a variable. And what is the lambda value? They already gave lambda value is equals to 10,000 and P value is equals to 2. So we have probability. So x is greater than 30,000. They are saying x is greater than 30,000, and probability of what we need to take? We need to take y value. This y value is x minus 20,000 and is greater than 10,000. We need to take probability of y greater than 10,000. Probability of y, because this is represented as what? This is represented as y. So probability of y is greater than 10,000. So now for this we are taking the integration part. So what will be the integration part? Integration 10,000 to infinity 1 by 10,000 per square into 1 by, in the place of p we are taking 2 into y power 2 minus 1 e power minus lambda by 10,000. This is the thing we need to do. So what we are assuming, y by 10,000 is u. We are assuming that y by 10,000 is u. So it will be u into e power minus u will be. So it becomes what? If you are assuming y by 10,000 equals to u, u into e power minus u into d, u is equals to what it becomes? It becomes minus u into e power minus u. Integration part infinity to 1 we are taking. Again integration 1 to infinity e power minus u into du. Here we are taking the limits, and here we are taking the integration part. So what it becomes? It becomes 2 by e, which equals to 0.7358. Next, coming to the fifth example, the probability density function of the time between the arrivals at the service station is what? Service station is, they are saying f of t is equals to 4 into e power minus 4. So what they are saying? So f of t is equals to 4 into e power minus 4t, e power minus 4t, ti. So what they are saying? The ti value should be greater than 0 only, greater than 0. So what is the question they are asking for then? So the question is probability density for the time to the 10th arrival. They are asking what is the time to the 10th arrival. We need a time to the 10th arrival. Assume that the arrivals are independent. So it does not depend on the other. So it is the independent thing. The time is independent thing. Coming to the solution, T1 denotes the warning time for the first interval. Wait, sorry. T1 denotes the first T1 denotes the waiting time for the first interval. And T2 denotes the time between the first arrival and second. First arrival and second. So it can be represented as what? So it can be represented as T is equals to T1 plus T2 plus so on T10. So we need to take sum of 10 in identical and independent distributed, right? So we are taking 10. So it becomes what? Function becomes f of x is equals to what is the formula? Lambda power p, t power p minus 1, e power minus lambda t by gamma function of p. So, so what it becomes? What is the lambda value? Lambda value is 4. And p value is equals to 10. So we are substituting the lambda value as well as p value here, so that we will get the value as 4 to the power 4 to the power of 10 into t power 9 into t power minus 40 by 9 factorial, where t is greater than or equals to 0. It should be not less than 0. So they are asking that only. So it should be greater than 0. 10th arrival, if you take the probability density function is what? The probability density function is this. This all sums are similar. You can do. They gave a p value and lambda value. You need to find out the mean. So what is the mean value? P by lambda. Then variance p by lambda square value. So it is very easy if you do that sums previously explained sums, and if you do check your progress or exercise sums, it is very easy you to do. So we'll have a glance here. Just so what is mean? Mean is p by lambda. If it is 3 by 10,000, it is 0.003. So variance will be this. So like that, all the values for the questions, these are the solutions actually. Okay, now we will go for the beta distribution. So applications of the beta distribution will do. So what is the beta distribution? What are the probability density function? All you know in the previous classes we discussed. So we will do what are the applications related to the beta distribution. So like first we will see what are the objectives we will do here. So after studying this unit, you will able to identify the situation where beta distribution can be used. So where we will use the beta distribution, that it can be what are the situation where you use the beta situation, we will see that. So to estimate the parameter of the distribution from the given data, we will estimate the parameter of the distribution. Coming to the introduction part, in the fifth unit of the block 2, we consider the theoretical properties of the beta distribution. In this unit, we will consider some numerical problems that illustrate the applications of this distribution. This distribution is used for making data involving proportions, is widely used in risk analysis. Where it is used? It is used in the risk analysis. Mainly used in the risk analysis. So coming to the first kind, so you know there are two kinds in the beta distribution. Let's come to the first kind. When coming to the first kind, f of x is equals to what? F of x is equals to 1 by beta of 1 by beta of a comma b, 1 by beta of a comma b. So it can be represented how? It can be represented as x minus m whole power a minus 1 into m minus x whole power b minus 1 by capital M minus small m into a plus b minus 1. So this becomes small m less than or equals to x and less than or equals to capital N. So 0 otherwise, and where a is greater than b and 0 and b and 0. So we take y is equals to x minus m by m minus 1. So we will represent it as y minus y power y. So what happens? This will becomes y power a1, a minus 1, right? So we will write like that only. 1 by beta a comma b, y power a minus 1. This can be written as 1 minus y, b minus 1, and 0 less than y, and greater than 1. So this is known as what? This is known as the beta distribution of the first kind. The formula which is there. So this is known as the beta distribution of the first kind. Beta distribution of first kind. Next, coming to the example sums. If you are coming to the example sums in the beta distribution of the first kind, mean of the distribution 1 by 3, and mean, they are saying mean as what? Mean as 1 by 3. And variance is equals to what? Variance is equals to 1 by 45. So what we need to do? Mean equals to what? The formula of mean. What is the formula of mean in the beta distribution? The mean is equals to what? Mean is equals to a by a plus b, which is equals to 1 by 3. And next one, variance is equals to what? Variance is equals to a by ab by a plus b whole square into a plus b plus 1. This is the variance formula. So after that, 1 by 3 is equals to 3a. Then it becomes a plus b, or b is equals to 2a. We can say anything. Why it is becoming like that? A by a plus b we are taking. It is equals to 1 by 3. I am doing the cross multiplication, which will become 3a equals to a plus b. So what happens then? I'm sending this a this side. So 3a minus a is equals to b. So B is equals to what? B is equals to 2A. B is equals to 2A. B is equals to 2A. Then coming to the variance. What is the variance? AB by A plus B whole square. A plus B plus 1 equals to how much? Equals to, they said, 1 by 44. So I'm doing the like from here only we can substitute. So what is B value? B value is 2A, right? So in the place of B, I'm substituting 2A. So into 2A by 2A plus A plus, here also I'm substituting. What happens is A plus 2A whole square into A plus 2A plus 1. Then what happens next? 2A into A by 3A whole square. It becomes 3A whole square into 3A plus 1. 1 by 45, right? 1 by 40. Okay. So 1 by 40. So what happens next? A into 2A by 3A whole square means what? 9A square into 3A plus 1 only I am taking equals to 1 by So what happens? This A and this A cancels. Another A and 2A cancels. So what becomes? 2 by 9 into 3A plus 1. 45. I'm doing the cross multiplication here. It becomes 45 into 2 is equals to 90. 9 3s are 27 plus 9. So I'm shifting this here. So 90 minus 98, 81 is equals to 27. A. So A is equals to what? 81 by 27. So 27 means what? 27 3s. So A is equals to what? A is equals to 3 and B is equals to 6. A is equals to 3 and B is equals to 6. This is very easy calculation actually. Okay. Next, coming to the other example. So from this you concluded, right? A is equals to what? A is equals to 3 and B is equals to 6. After solving this, you'll get the thing. Coming to the next example. So it is required to estimate the duration of the time required for the completion of a project. So what we need to estimate? We need to estimate the duration of the time required. They're asking required. How much is required to complete our project? So minimum duration, they give what? Minimum duration is 6 months and maximum duration is 12 weeks. Sorry. So minimum duration is what? 6 months, 6 weeks. And maximum duration is what? Maximum duration is 12 weeks. So expected duration they are giving between that like 8 weeks. So the coefficient of the variation of the duration is 10%. They are taking 10%. Sorry. So what they're saying, the expected duration is 8 weeks, and the coefficient of the variation of the duration is 10%. They are saying 10%. So what is the probability that the project will be completed within the 10 weeks? So they are asking expectation that 10 weeks hypothesis. What is the probability they are asking? For the generalized beta 1 distribution, we are using the first kind, right? So that's why I'm saying beta 1 distribution or as beta distribution first kind. So the formula is f of x is equals to x minus m power a minus 1 into m minus x whole power b minus 1 by beta of a. Like this can be written outside also, 1 by beta power beta a comma b into m minus m a plus b minus 1. So, which is the integral part of m less than or equals to x less than or equals to capital M and 0 otherwise. So, what is the mean here? Mean is equals to MC by HA by C. So, what is the things we are seeing? What is H here? H is equals to capital M minus small m. We have small m and capital M also. So, what is the H value? The H value is capital M minus small m. Capital M minus small m. So C, what is the C value? C value is A plus B. A plus. So what is the variance value then? Variance is equals to H square AB by C square A plus B plus 1. A plus B plus 1. So here from now with what we are taking M is equals to 6 and H is also 6. So we are substituting here. So what is they are expecting? 8 is equals to uh, 6 plus 6 into A plus B. A plus B. So what it becomes? So 6, it comes when this 6 comes this side, it becomes 2, 8 minus 6, 2. So 6A by A plus B. 6A by A plus B. So 2A plus 2B is equals to 6. So what is the B value then? B value is equals to 2A. B value is equals to 2. So now what we are doing? Sigma by mu. Anything else is given in the question? We'll see once. They asked to is completed within the 10 months they are asking. Coefficient of variance also they are asking. Coefficient of variance. So coefficient of variance is how much? 10%, right? So coefficient of variance is equals to sigma by mu into 100. Sigma by mu into 100. So what is we can write it as 0.1, 10%, right? 0.1 into 8 whole square. Expected is 8 whole square. So, which is equals to what? H square AB by C square into 8 plus 1. C square into 8 plus 1. So, H square, we got H square value, that is 6. So, 6 means 36. So, A value we know. AB value what? AB value is 2. B is equals to 2A, right? So A is A only. So it becomes 2A square. 2A square. So then C value is what? C is also 3A square plus 3A is 3A plus 1. So, like this we are substituting. So after substituting, this is 0.1 into 8 square, right? Same 0.8 into 8 square. Same thing we are doing here. So what happens? 0.1 square means what? 0.1 square is 0.01. 8 square means 64. So 36 into A into 2A is 2A square. 3A whole square into 3A plus 1 is 9A square into 3A plus 1. So how I'm taking this thing left side. So 3a plus 1, what it becomes? 3a plus 1 is equals to, this becomes 25 by, this a can be cancelled easily. A square can be cancelled. Let me explain clearly, right? So what? 36 into 2a square by 9a square into a plus 1. This is right side. Manaki right side undi kada idi. So what I am doing means this a square can be cancelled. So 9 ante 9 ones are 9 fours are, right? 9 fours are. So what we are having? So 8 by 3a plus 1. 8 by 3a plus 1. So I am giving this side. And what is that? 0.01 into 64. So this comes this side. What is the value? So 3a plus 1 is equals to, they are taking it as 25 by 2. So 25 by 2. This 2 comes this side. 6a plus 1 is equals to 25. So 6a is equals to 23. A is equals to what? A is equals to 23 by 6. 23 by 6. So if you are, what is b value? B value is what? B value is 2a, right? B value is 2a. So B, what is 2 value? A value 26, 23 by 6, right? 2 ones are 2 threes are 23 by 3. So A value is what? A value 23 by 6 and B value is 23 by 3. So the required probability is what? So Bx of 23 by 6, comma, ante A comma B, and B of A comma B. That is 23 by 6 comma 23 by 3. Next. So what is the value we are getting? We are getting the value as x is equals to 10 minus 6 by 12 minus 6. This becomes 2 by, this becomes 2 by 3. So obtained is what? 2 by 3 means from the tables as beta tables, we can conclude the value as 0.001048. This is the value we are getting from the beta table. So coming to the next example. So next example is what? So next example is for the beta distribution of the first kind. They are already giving the mean. Mean is what? 2 by 5. And mode is what? 1 by 3. So find the probability of the function of the distribution directly as first question we did. So same as that. So same as that. So they gave what? Mean. So we know what is mean value? A by A plus B, which is equals to, they are saying 5. And mode value, what they are saying? A minus 1 by A plus B minus equals to 1 by 3. So what happens if we do cross multiplication here? So m is equals to 5a is equals to 2 into a plus b. This equals 2a plus 2b. This comes this side, 3a is equals to 2b. A is equals to what? 2b by 3. 2b by 3. So in here, if we substitute a is equals to 2b by 3, or then we'll get the value in the next video. 3a by 2. So I'm substituting 3a by 2 here in the place of b. So if I'm substituting 2a plus 1, so we have a minus 1 by a plus 3a by 2 minus 2 equals to 1 by 3. This comes upward, right? So this becomes 2a minus 1, a plus 3a. Means becomes what? A plus 3a by 2. So first we need to take LCM, right? So LCM తీసుకున్నాక we need to do. If we take LCM, what happens downward? A plus 3a plus minus 2 by 2, right? Uh, this becomes 2a plus 3a minus 4 by 2. Okay, this becomes this. So this becomes 5a minus 4. That's why we wrote 5a minus 4. 5a minus 4. So what happens? 2 into a minus 1 by 5a minus 4. So what we need to do? We need to equals to what? 1 by 3. So I'm doing cross multiplication. If I'm doing cross multiplication, it becomes 2 into a minus 1 into 3 equals to 1 into 5a minus 4. So what this becomes? 3 into 2 is a minus 3. 3 2s are 6, right? Sorry, so let me correct it. So directly I'll write here only. 2 3s are 6. 6a. 6a minus 6 is equals to 5a. 5a minus 4. So 6a, I am taking this 5a this side. Minus 5a equals to what? Minus 4 plus 6. So this becomes a is equals to a is equals to. So we got the a value. So now we need to find out the b value. So how we will find the b value? In any of the equations, we'll substitute in the previous equation we have, right? So what is the equation? A by a plus b. Okay, from above one only we'll take the equation. So what is the we have a plus a by a plus b is equals to 2 by 5. Okay, we'll do that only. A by a plus b is equals to 2 by 5. So what is the a value? A value is 2. I'm substituting 2. 2 by 2 plus b. Any equation you can substitute the a value, you will get the b value. Not in the previous equation or any equation. So from the above equations, if you have any b and a values, you can substitute it in any of the equations to get the other value. So this becomes 2 by 5. Easily we can say this 2 can be cancelled. What happens when we take reciprocal? 2 plus b is equals to 5. Then b is equals to what? 5 minus 2. B is equals to B is equals to, we got the 3 value, right? Yes, 3. So we need to substitute in the equation, right? So we need to substitute in the equation. Sorry. So f of x is equals to what? F of x is equals to 1 by beta of 2 comma 3 into x power 2 minus 1 into x minus 1 minus x 3 minus 1. So this is the required f of x probability density function for the beta distribution of first kind. So 0, otherwise we'll take. So we have the second kind. Similar problems we have. Same 1, 2, 3. 3 more sums are there to complete the beta distributions. And the next tomorrow class, we'll complete that. So once we will record the formulas, right? Or else we'll continue with the second. Okay, we'll start the second kind first sum. It will be easy. Same similar process. Okay. So the probability density function of the second kind of the beta distribution is what? This. So what is the distribution? PDF f of x is equals to 1 by beta of a comma b into x power a minus 1 by 1 plus x a plus b. So for what? For x is greater than 0 and a is greater than 0 and b is greater than 0. and we'll take 0 otherwise. So if we substitute 1 by 1 plus x, then it becomes what? So this becomes different. So this becomes, so y power a plus b, 1 minus a, 1 minus y, a minus 1 into 1 by beta power a comma b. This becomes like this. If we substitute y in the place of 1 by x. Next, coming to the problem. Uh, I'm sorry. So what it is? So mean, we have mean is equals to a by b minus 1 is equals to 1. And what it becomes? A is equals to b minus 1. So this is mean. And variance is what? Variance is a of a plus b minus 1 by a b minus 1 whole square into b minus 2. B minus 2. So equals to 2. So in this place, what I am substituting means, in the place of b, I am substituting a plus 1. So in the place of b, I'm substituting the a plus 1. Then it becomes what the equation becomes? The equation becomes a into 2a by a square into a minus 1. So this a square, this cancel, equals to 2, right? This 2 cancel. 1 by a minus 1 is equals to 1. A minus 1 is equals to 1. A is equals to 2. I got a is equals to 2. So I'm substituting the a value in one of the equation, mean equation. Then I'll get 2 by b minus 1 is equals to 1, right? So 2 is equals to b minus 1. So b is equals to 2 plus 1. So b is equals to what? B is equals to 3. This is the b value. A and b values are this. So now we want what? We want the function, probability function. So what is a probability function? So probability function is this. So probability function is f of x is equals to what? F of x is equals to 1 by beta of a comma b. A comma b means what is a value is 2 and b value is 3. Then what is x power 2 minus 1 by 1 plus x power 5. This becomes x greater than or equals to 0. X greater than or equals to 0. Or we can take 0 otherwise if this condition does not work out. So these are the things we learned today. So what are the things we covered here? We'll have a glance. So gamma distribution also we completed, I think so. These all things, the applications of the gamma distribution examples. So how mean variance is given. So if mean and variance are given, so how to find out the distribution. And they're asking us in the second question, they're asking us to find out the x is greater than 2, the probability you need to find. And third one, you need to find the density function of the water. And coming to the next question, you need to find the stock which is insufficient. So we are finding the stock which is insufficient. In the fifth question, what we are doing? In the fifth question, we are finding the probability density function for the 10th arrival. So 10th arrival. So next, coming to the beta distribution is very easy. So when coming to the first kind, so they already gave the mean and variance. So from mean and variance, you need to find out the A and B values in the first question. In the second question, what they're asking the probability to be, they gave the 10 weeks as the expected one, complete within the 10 weeks. So you need to find the probability for that. And coming to the next third examples, they already gave the mean as well as the mode. So you need to find out the probability density function actually. Probability function of the distribution. So in the beta distribution of the second kind, what we did in the second kind, they already gave the mean as well as the variance 1 and 2. So we need to do what we need to do. We need to find out the parameters that are A and B, and then next you need to find out the probability density function. So in the next class, we'll complete the remaining sums and we'll go for the next distribution. Thank you.